Hello class, welcome to our lesson for today, dealing with section 4.2, more translations of the graphs of sine and cosine. Today what we're going to focus on is what the graphs look like with certain situations, just extending on what the horizontal or phase shifts are and what the vertical shifts are, along with x and y, or x-axis reflections and period and amplitude changes. The goal for most questions to get set up is everything that's on the left side here. So for example, the amplitude is 2 because the number in front of sine is 2. The period is 2 pi over 4 because the b value here in front of x is 4, which is pi over 2. And then the minus 1 moves everything down 1. That's a vertical shift of negative 1 then. If you can do those pieces, your homework should be able to kind of work itself out if you can find out what all of the situations are. Notice here I moved my equilibrium down 1. And then my graph has to go up, come down, and back, okay, in a distance of pi over 2. So instead of being at 2 pi, it's pi over 2, so it's shrunk down a lot. So when you're dealing with those situations, you want to make sure that you're looking at it from that perspective in order to graph the function of this trig equation. The next one has an amplitude of 3 because the number in front of cosine is 3. It's also a negative 3, so there's an x-axis reflection, which means instead of going in the upward direction first, instead of being above the equilibrium first, it's going to start downward or below and work its way up. Okay, so it's a cosine graph flipped around. The period here would be 2 pi over 2, which is just pi, and then the graph has been moved up 1 because the number out front by itself is 1. So the equilibrium has moved up to 1. And what you'll notice here is that from equilibrium, I'm going up and down 3. So down 3 from there and up 3 from there. Normally I start above and work my way down for cosine, but because it's flipped, I need to start 3 below the equilibrium, go up and then back down in a distance of pi. When you're trying to pick graphs that match, okay, whatever the equation is, like if you're looking at a multiple choice homework question, what you want to focus in on is what's the period and how far away is it from the equilibrium point. The next equation has an amplitude of 1 because the number in front of sine is just a 1, there's nothing there. Up 1/2. Notice that this is that factored form that's important when you find the period and the shift left or right. So the period here would be 2 pi over 2, which is just pi, and the graph is moved to the left pi over 4. When you're graphing things by hand, it's important that the graph paper matches whatever the phase shifts left and right are going to be. But when you're dealing with graphing on a utility, like on your homework, for example, it's really irrelevant about those pieces. You should be able to find any answer you want. Notice here, I started with these points of what it would have been if I wouldn't have had a shift to the left or right, and then I moved all those points to the left, one location for this pi over 4, and then that would be one period of that graph. Remember, the period has shrunk down from 2 pi to pi. The amplitude is still 1, so it's still going up and down 1, but it's from 1/2 as the main equilibrium as opposed to the x-axis. A lot of what you need to be able to do is just to find the information, as opposed to being able to graph all the time. So for this first question, the amplitude is 1, the period is 2 pi because there's no number in front of the x, and then it moves up 2. Some students will say that's a phase shift of 2 to the left, but remember it's a difference of in parentheses, so compare that with this one on the bottom right. This is right pi over 4, because it's in parentheses, it's moving everything to the right then. The period is 2 pi because there's nothing in front of the x, and the amplitude is 3. This one at the top right, amplitude is 1/2. The period is still just pi, but it's moving down 4. And when you use your graphing utilities on your homework, you may have to plug that in as a vertical shift of -4. So that's why I'm writing kind of both of these versions for you to look at for a vertical shift. This next one, the amplitude is 2, period is 2 pi. That one's pretty straightforward. There's no moving left or right or up or down. This next one, the amplitude is 1. Some students will think that's a 3, but remember that means move the graph up 3, so that moves the equilibrium, so your graph is all shifted upward. The period is still 2 pi because there's no number in front of the x, and then you're moving to the right, pi over 4, because it's negative pi over 4 on the inside, which means when you solve for x, it becomes regular pi over 4, which is always to the right in our coordinate plane. That's everything for today's lesson. Remember when you're focusing on your homework to find the amplitude, find the period, the phase shifts, the vertical shifts. Okay, those ideas are going to be central to be successful on your homework and your assessments. Make sure that for these questions, you're focusing in on sine and cosine graphs. We're going to be doing secant, cosecant, tangent, and cotangent later, but a majority of our focus is going to be on the sine and cosine graphs. Have a great day, everyone.